Well, hello, everyone, and welcome to the 2021 Better Buildings, Better Plants Summit. I'm Kathleen Hogan, the Acting Undersecretary for Science and Energy at the Department of Energy, and thank you for joining us today. We really have a wonderful session for you, fantastic speakers, which I will introduce in just a moment. But first, I want to run quickly through how this session will work. Attendees, you will be in listen-only mode, meaning your microphones are muted. And certainly if you experience any issues, audio or visual, please send a message in your chat window at the bottom of your Zoom panel. But this will be an interactive session. We want your questions, we want your feedback, and we'll be using an interactive platform called Slido for question and answers, polling, and session feedback. So please go to slido.com using your mobile device or by opening a new window in your internet browser. Quickly find today's event code, #DOE, and after that, select today's session title in the drop-down menu in the top right, that session title being Emerging Trends and Technologies from DOE's National Labs. And if you have questions for the panelists, please submit them in Slido at any time. Just get them loaded in there so that we can be ready to go. And we will answer these questions a little later in the session, about halfway through. And again, if you have any issues, please message tech support by using the chat function in your Zoom panel. And finally, just so you know, the session will be recorded and archived on the Better Buildings Solutions Center. So onward, I really am delighted to be here with you today as part of this panel. This session is always one of the highlights of the summit, and we're glad all of you can be here with us. As we all know, we've got very ambitious goals in the coming years for energy efficiency, clean energy, and here in this session, we can look toward the future and the possibilities that it holds. Let's just think about some of these goals. Net zero carbon economy by 2050, carbon-free electric grid by 2035, deeply decarbonized buildings, transportation, and industry with a strong US competitive clean energy manufacturing effort, good quality jobs, and providing benefits to all our communities, really emphasizing equity and justice. To achieve these big and really critically important goals, we need leadership everywhere we look, leading examples, and that is why we're all excited to be here with you, exploring what we can do together and exploring what you can do as well as you continue to define and showcase your leadership. So now we're going to talk with three leaders from three of our national labs, and we will ask them to talk about several things, two or three, that they're most excited about and how these things have the possibility of being game changers for you, your organization, and the way we use energy in our buildings, homes, and manufacturing plants, really throughout our economy. So this is going to be hard for each of them. We're giving each of them only 7 to 10 minutes to do these, to present this really great information. But we really also want to leave time for your questions too. So again, please make sure you use Slido and become part of that conversation. So without further ado, I will introduce our first panelist, Martin Keller. Martin Keller is the director of the National Renewable Energy Lab, where he's been since 2015, where he applies private sector best practices to achieving game-changing scientific outcomes. His strategy for driving NREL's work, along with his leadership team, focuses on three key initiatives: the integrated energy pathways, the circular economy, and electrons to molecules. Martin, you're on.
Thank you, Kathleen. So thank you to all of you wherever you are, and I'm glad to walk you through at a probably very quick speed what we want to talk about in the building sector. But I just want to take one kind of the key message away at the beginning. And you see this already also in my presentation in the slides. So buildings will be vital to achieve the 2035 clean energy goals. So we cannot do it without buildings. And I hope I can explain this to you why it's from a research perspective, super exciting what's going on in the building side. So the next slide, you're seeing just a couple of highlights about NREL, just in case you don't know. So okay, here they go. So we're about 3,000 people. We're having a very nice facilities. We are in Golden, Colorado, and focusing on energy efficiency, renewable energy, and the clean energy transition. So the next slide shows you the so-called mega trends. So what I want to show, I think yeah, perfect. Thank you. So there's things like cyber threats, electrification, and so on. So I just want to highlight a few of them, which are also critical for the energy transition, and especially related to buildings. The next slide shows you this so-called population growth. We all know that we're dealing with a big population. 2050, we have about 9.4 billion people. We're using much more resources that our planet provides. And again, a lot of these people, as you can see on the next slide, are moving into an urban setting. So every week, 1.5 million people move into a city. So the question is, how do we keep this city livable? How do we provide the resources to the cities? How do we create the energy, the water, the food, and so on? So a big challenge, a lot of good opportunities also to increase our infrastructure needs across the planet, but also cities will be the big focusing on the energy transition, on not the change. So the next slide shows you then when we bring up advanced mobility. And again, this is now where it's getting very interesting, because suddenly, historically, transportation was always uncoupled from buildings. And now with the electrification of our transportation, now suddenly all this morphing together. And you also will see how this will change our grid architecture because of this. So the next slide shows you how our electric power system is changing. So currently, we're having large central stations, synchronous generation, a central control point. We have dispatchable generation, and which follows the demand. The future of the power system will be much more variable, more power electronics, more information, and more distributed. So when you see that for the decarbonization, we will see an increased level of wind and solar and variable power electronics on our grid. We see the digitalization, a lot of this, and we'll come back to this one, is run through big data and information. It will be much more distributed and interdependent. And again, this is what also will bring a lot of challenges to the grid of the future. So the next slide shows you that there now where buildings come in, and especially behind the meter solutions will be an integral part of the future energy solutions. So that's where we're moving to, that everything will be integrated. We have our electric vehicle, we're charging them, we have battery storage, we have thermal storage, we have solar panels on our rooftop. All this behind the meter will be, so the grid on the edge will be key for the future system and how we're integrating all this together. So the next slide shows you just one slide to see that the grid interactive energy efficient buildings research at NREL, we feel that this is very, very critical and vital, again, to reach our 2035 and 2050 goals. So we're working on developing building technologies and controls that reduce energy consumption. We're developing new thermal energy storage materials. We're developing advanced building construction methods and so on. And especially very important, also the skilled workforce. This will be a big challenge, I think, for us in the future. How do we train the people who will keep all this functional and operational, not only from the installation, but also from the service sector side? So this will be a very, very large challenge for us in the future, I think, here in the US, and I think also globally. So the next slide shows you now how all this is it's tied together. So historically, we work on single buildings. We put smart thermostats in our buildings, and we manage the kind of load and energy consumption within our buildings. But now we're moving this out to neighborhoods, from there into community and towns, and from there into large city. All this will be interconnected, which will be a great opportunity, but it's also a challenge how we actually accomplishing this. So the community scale solution is where we're now moving into this, that we, again, what I said, connecting different homes together, to go from some individual homes, and suddenly then we're connecting them together with what we call here the community aggregator, and suddenly 500 homes roughly will be connected. And this will be a tremendous opportunity to manage the building loads and help the utilities also to manage the loads in our grid. The key is also the challenge. How do we integrate all this together from one building with smart meters, thermostats, water heaters, battery storage, distributed PV from one building, and connect another, let's say, communities like 500 buildings within a subdivision together to then go and correlate all this up to the big cities. The next slide shows you where this will go. So what we call autonomous energy grids. The future of the grid will be so complex and will be so many controllable devices on our grid that the traditional way of controlling our grid will not work anymore. It will be autonomous. It will be done by machine learning, by smart algorithms. And this is the challenge. Again, how do we develop the algorithms to do all this? And also, how do we keep it safe? How do we keep the bad actors away, that they basically come in through a solar panel and turning our lights off? And this is where cybersecurity will play a major role in the future grid architecture for us. The next slide shows you, when you look at just right now the Bay Area, and this is again what we modeled and simulated one of a high-performance computer, and asked the question, so if everybody in San Francisco Bay Area has a PV, a storage in batteries, electric vehicles, smart thermostats, smart appliances, and so on, alone in the Bay Area, we're talking about 10 to 20 million controllable devices. So 20 million. When you talk about this, the current grid on the Eastern grid is controlled with about 10,000 control points. So alone the Bay Area will have 10 to 20 million controllable devices. This is where the challenge will come in. This is where we need new algorithms, new ways how we actually control the grid architecture and the grid of the future. So the next slide, so I think you're a little bit behind. So if you go to, one further, please, to the Aries slide. So now the really interesting thing is, how do we connect all this together? How do we bring the modeling, the simulation, and then how do we take all these devices through emulations where we take live data from different equipment and bring this together, that we can actually check and make sure that the new algorithms we're developing working, how our devices work. And this is what we're working on, this called Aries Platform. So this is bringing together our energy systems integration facility, which goes up to 2 megawatts, where we basically can simulate different appliances, electric charging vehicles, you can see on this picture there. And then this goes up to Aries, which is then 20 megawatts, where we have wind turbines and solar panels and battery storage and electrolyzers to produce hydrogen. So you can take all this together through emulation, where you then can model and simulate with live data from different equipment to a size which is behind a substation, to be ready for the utilities to then roll this technology out to the market. So we are very excited about this new investment DOE is bringing to NREL, because this will be the platform to integrate all these different technologies together. So the next slide, please. So it shows you one other big thing what we have done lately, and you might have seen this. And if you have not seen this, I encourage you to look at our website under the LA 100 study. This was a big study in Los Angeles, where Los Angeles came to us and said, what will it take to go to 100% renewable energy? What can we do? So this study, where we did over 100 million high-performance computing simulations, where we modeled every rooftop to see if it can take solar panels on there, where we modeled the transmission lines, where we modeled electric charging station for cars, coming to this conclusion that yes, we have a couple of things where we still have to figure out how we're doing this, but there is a path in LA to 100% renewable energy. And what was also very interesting on this study, and this is also working very deeply with the communities, and I will come back to this one in the next slides, but also brings a cost to the consumers. So by going through all the different scenarios, we also can now predict what the cost will be actually back to the consumers. And it also will have into the models the kind of resilience of our grid. What will happen by having this more distributed system with wildfires and so on. So I encourage you, look at our website. This was once a lifetime study, which is very interesting. And now the question is, how can we roll this type of implementation plan out across the whole United States? So the next slide shows you now the big thing, which also the Biden administration prioritizes, and Kathleen brought this up, to see how we're doing this in energy justice. How do we bring everybody around in this energy transition? Historically, when you look into research development, moving to demonstration to deployment, a lot of times we are really not doing this demonstration, deployment, and the research with a focus of underserved communities. And this is, again, where we need to do a better job right now to also look into these communities, work with these communities to bring them along in the energy transition. So the next slide shows you one of the so-called trickle-down energy research, what we normally do. A lot of the new research we're doing, let's say, in a new subdivision, where we're looking into the kind of people who are first out there to see, well, they want to have solar panels on the rooftop, or they want to have a new thermostat in the house. So a lot of times, we are focusing on the research on the first adopters of some of these technologies. But we also need to look into the historically marginalized communities and work with them and design research and experiments also for these communities, because it's very different if you have a new subdivision to make the transition, or if you go into an underserved community and ask them with energy transition. So this is something where we really have to put much more focus on to bring everybody across this energy transition. And then the next slide shows you the clean energy transition implementation plan. So the key is when you see how do we do what we learned from LA, what we learned from our work, for example, with kind of different communities in rural settings, or also in the cities. We have to do stakeholder engagement. We need to work with the people and bring them along. And then have to integrate this with analytical insights, models, and tools. We have to create solution and technologies to bring the cutting edge technology there. We have to create action plans and implementation plans. Again, what I also showed you on the LA 100 study is not enough just to do some of the modeling. We also have to create this into an actionable plan. And then we have to do a community-driven national impact. So this is a big challenge. I think, as what Kathleen said, that's very ambitious goals. I'm very optimistic. I think we can achieve this, but it will take everybody. It take all people on deck to get this done from all communities across the United States. And the next slide now shows you that partnering with industry is, in our point, critical to accomplish this. The next slide shows you that this is, in the transition, this is where we can create great American jobs, we can boost the US economy, and we also can strengthen our energy security. But it has to be in new teams. We have to form new public-private partnerships to really accelerate the energy transition. So the next slide shows you a couple of our big partnerships. As you know, we have a lot of partnerships at NREL. I think they are critical. I talked about the LA 100 study, which was a wonderful partnership with LA to accomplish this. So we have a very encouraging partnership with Dallas-Fort Worth International Airport, which also goes towards the electrification, the connectivity of new airports and transportation systems. We're working with companies such as Eaton, which are actually now located at our facilities. And we're also working with companies like Wells Fargo to do some incubator space. And again, I apologize, I switched the two text between Eaton and Wells Fargo. So with this, I want to give it back to Kathleen. So in the next slide, I want to say thank you. So we have a lot of things ahead of us, so we have to get going. Time is of essence, but I'm very optimistic we really can do this. And again, what I said, buildings will be the centerpiece. They will be the integrator of bringing all these technologies together. So thank you. Kathleen, back to you.
Martin, thank you. Fabulous job. I think I have time for one question here of my own for you. You spoke about a very different world, a changed energy grid with these buildings at the center in this country. And you talked about something of where we would be going in any number of years. But what is it you think people should really be focused on today as they get ready for this rapidly and very dynamic changing space?
Yeah, look, I think you said it exactly right. I think it's changing rapidly, and it's very dynamic, and it's very fast moving. So I think for everybody in this industry, I think it's really important to keep up where the technology goes. So I think it's very, very important that we, through meetings like this, honestly, is where we're building the network, where we're knowing where the technology goes, where we're starting to transition our buildings, that we're having this in mind, that they all will be connected, that we are starting to bring this technology into our buildings. And there is so the so-called low-hanging fruits, and we will talk about this to make it more energy efficient and be moving this along. And I think that's very important. But then we also need to prepare our buildings on the site to be able to accept some of these new technologies, from smart thermostat to for example, charging stations, especially if you're working in the industrial sector. I mean, sooner or later, I mean, if you have, let's say, if you're a little shopping mall, I mean, there will be charging stations linked to this. It will come. So what can we do right now to really prepare for this transition? Because everything what we are seeing is that this is accelerating. And for example, when we talk with companies such as Eaton Corporation or Siemens or Schneider, I mean, to name a few of these players who in the sector, this is super fast moving, and I think we need to be alert what's coming down the pipe, that the people in the sector know where the technology goes, being informed, training our people to accept some of these new technologies, and getting our buildings ready to start installing some of these new devices. Because as you all know, what you've seen in the transportation sector, the electrification will go pretty rapidly. And so we in the building sector, we have to be ready to have our customers want to charge the cars in front of our buildings, as an example. Or if you build a new subdivision, it will be a lot of the houses will be electrified. So it's coming fast.
Well, thank you. Let's move to our next speaker, and that is Angela Becker-Dipmann. Angela is the director of the Pacific Northwest National Laboratory Energy and Environment Directorate's Program Development Office. And here she evaluates policies and programs to help ensure the most impactful outcomes for the lab. She's been with PNNL coming up on a decade, with a little time out in the middle to serve as the staff director at the U.S. Senate Committee on Energy and Natural Resources, a committee that had jurisdiction over many of DOE's programs, as well as the U.S. Department of Interior. Happy to have you with us today. Angela, take it away.
All right, well, thank you. Thanks, Kathleen, for that introduction, as well as to the Better Buildings team for inviting me today to talk about some of the cool things we're working on at the Pacific Northwest National Lab. So I think, first off, Martin laid out a really very compelling vision of what the future likely will look like. And we very much share much of that vision at PNNL. So I want to spend a little time describing the way we're partnering with industry to operationalize some of these smart grid integrated building concepts for the commercial sector on the ground. I'll also touch briefly on a couple of other concepts more and more central to building operations, namely resilience, cybersecurity, and also what we're learning about viral transport in buildings on the heels of COVID, as we consider not just efficiency, but health-related outcomes in the built environment. So next slide, please. So in the Pacific Northwest, we've got a pretty rich policy-driven history of energy efficiency savings as the resource of first resort. And today, enabled by advances in building materials, sensors and controls, and again, a supportive policy environment, we're taking the next step toward grid-optimized net zero energy and zero carbon buildings. Here you can see an illustration of the South Landing Eco District in none other than beautiful Spokane, Washington. It's been developed through a joint venture between Avista Utilities, the local utility, and McKinstry, which is a Seattle-based construction and engineering firm. The South Landing development is at present comprised of two commercial buildings of just about 200,000 square feet combined. The larger 5-story Catalyst building is going to be occupied by Eastern Washington University students come this fall, alongside commercial tenants. The smaller 4-story hub building is going to house both leased space, but also the central energy plant, pooling and distributing energy to Catalyst, and eventually to other buildings as the site is more developed. So from the outset, the vision's been to lower the carbon footprint at every stage in its development. First off, the developers took some different construction approaches, rethinking supply chain management, basically. And in terms of building materials, every effort was made to replace, to lower embodied carbon by replacing steel and concrete where possible, and replacing it with locally and sustainably sourced cross-laminated timber for both structural materials as well as factory fabricated tip-up panels. In terms of on-site energy management, which is the stuff that gets PNNL researchers and Martin's researchers at NREL super excited, the project relies on solar PV and both battery and thermal storage, along with managed EV charging capability. It's also leveraging high-performance air handling systems that can be configured to meet fluctuating demand from occupants. For our part, PNNL researchers, in partnership and with the support of DOE's Building Technologies Office, are demonstrating new integrated and interoperable control approaches for the systems within these buildings. Those approaches are designed to coordinate the systems to respond to the needs of the local distribution system. We call this Transactive Control, which is a new approach we've developed on our own campus and in connection with other DOE grid modernization projects in the past. I guess transactive control is sort of a fancy term, but at its heart, it reflects the merger of economic theory and control theory to manage building systems to deliver more comfort, operational efficiency, reduced operating costs, while enabling automated response to incentive signal from the local utility. And the idea here is to move from traditional demand response paradigms to autonomous demand management. And our ultimate goal is to design control approaches that are going to be turnkey solutions broadly available, as opposed to the custom jobs currently required for this sort of functionality. And then in this particular case, the eventual plan is to extend this grid responsive capability to the neighboring communities served by the same substation as the South Landing development. And that's going to include 2 economically disadvantaged neighborhoods in Spokane. And Martin talked earlier about connecting residences. For our purposes, we plan to start with commercial and light industrial loads in terms of being able to access more flexibility. In addition, I'd mentioned we're working with the state of Washington through its Clean Energy Fund, essentially to examine rate and tariff structures and different use cases to explore different potential services this shared energy model can provide. And importantly, how best to properly and equitably value those services. So we're really excited about the potential future for this model, especially if we're successful in doing this at costs on par with the market for commercial developments, which is the goal. I also just want to mention a couple of other areas where we're making advances with respect to refining buildings' operational strategies. So next slide, please. One is resilience, and trying to better understand and quantify the crosscut between efficiency and how it can contribute to resilient building operations. Today, our building codes put a value on things like fire safety. So the question we're assessing and asking is, can we put a value on measures that enhance both resilience and efficiency? So we're exploring the kinds of trade-off analyses that may result in better buildings at lower cost that are lower cost to operate and more resilient to events including high water, high winds, and flooding. Next slide, please. And as we're developing these valuation metrics, we're also in collaboration with the Federal Energy Management Program, or FEMP, developing a suite of tools to help assess risk to a site's critical functions from disruptions in energy and water utility disruptions, essentially. Then we can use this assessment to help prioritize solutions that reduce the most important risks. And again, so far we've piloted these tools on our own campus, and we had plans to do this at 6 different federal installations last year, but we were pretty limited in that by travel. So those efforts have been mostly virtual so far. So as this suite of tools matures, we really do hope to work with the Better Buildings community to exercise them in the commercial context. Next slide, please. In a very similar vein, we've been working with FEMP on developing methods for assessing cybersecurity of buildings and the systems within them. This goes hand in hand with the use of sensors and data to automate building controls. So we started with best practices that had already been developed by NIST and ASHRAE and frankly, the Department of Defense. And we created a framework that provides a sort of heat map for a facility or installation that points toward the kind of cybersecurity considerations you might want to prioritize. And from a federal perspective, it allows agencies to compare themselves to other agencies or compare buildings across their portfolio. And again, in the case of both the cyber and resilience tools, we probably honestly have another year or so of ground truthing, but they're both areas where we hope to work with the Better Buildings community and would love to know your thoughts on how to make these tools most accessible and valuable to commercial building owners. So next slide, please. And then finally, in this day and age, where would we be without mention of global pandemic? As it turns out, factors impacting the ways viral transmission can occur in the built environment were not all too well understood at the outset of the COVID crisis. And interestingly, it's kind of one of those areas where national labs were uniquely positioned to help make a crash course effort to help figure it out. In our case in particular, I can say we had a former epidemiology professor working down the hall from buildings engineers and HVAC experts, right? So in addition, in the first months of COVID, we definitely heard tale of utility bills on the upswing due to spending on added airflow on campuses and buildings, even as they were mostly basically vacant. So our initial modeling, though, tells a bit of a more nuanced story, really. While outdoor air circulation and filtration provided expected benefits, it turns out vigorous and rapid air exchanges within multi-room buildings are perhaps not always a good thing. The study suggested, this modeling has suggested that these rapid air exchanges can quickly spread the virus from a source room into other rooms at high concentrations, basically like how secondhand smoke spread from one room to another back in the day, which is actually kind of intuitive. COVID particle level spikes in adjacent rooms could occur within 30 minutes and remain elevated for up to approximately 90 minutes. So we're working with Berkeley and Argonne National Labs on some more experimental studies to help complement the modeling. And so more to come on that. But certainly it underscores our growing understanding, really, of the link between health and the built environment, which is a trend we expect to see continue through our work in partnership with the Department of Energy and the Better Buildings community. So I'll leave it there for now, and thanks for the invitation once again. And I look forward to the discussion.
Great, Angela, covered a lot of ground there. A lot going on. And let me just follow on with the health thread, because as you said, it's really so important right now. So what would you say managers of buildings and plants across the country, what should they really be paying attention to with the health concerns in our built environment, and how can they get started today on a good one?
I think certainly, there is the issue of viral transport that has been incredibly important over the last, 14, 15 months, for sure. And another factor we've been thinking about here on the West Coast in particular is air handling in the context of a changing climate and forest fire, and understanding the nexus between air quality and air handling and efficiency. Where I think we've probably got more work to do in collaboration with the commercial building sector to understand all those dynamics. On a more optimistic note, I guess you could say, one of the areas we're really excited about is the work we're doing on advanced lighting solutions. And essentially the health and productivity related impacts of tunable LED lighting, where we're beginning to understand the physiological and psychological benefits of tunable lighting solutions. And again, the solid state lighting program at DOE has been central in beginning to understand the connection between these factors. So that's an exciting area as well, I think.
Absolutely. Well, thank you. So let's move on to our third panelist today, Tom Kurfess. Tom is the Chief Manufacturing Officer at Oak Ridge National Lab. From 2012 to 2013, while on leave, he served as the Assistant Director for Advanced Manufacturing at the Office of Science and Technology Policy at the White House, where he coordinated federal advanced manufacturing R&D. He was president of the Society of Manufacturing Engineers in 2018 and is on the board of the Governors of American Society of Mechanical Engineers. So his work spans digital manufacturing, additive and subtractive processes, and large-scale production enterprises. Tom. Mute. You're.
Like we haven't done that before, right? Thank you, Kathleen. Right. Anyway, so thanks very much for the intro. I'm going to talk about manufacturing, and really the title of my talk, it depends on how you want to look at it. Punctuation's critical. My kids told me that. They said, just look at the sentence, let's eat grandma or let's eat grandma, right? I mean, these are kind of critical things. And it's the same thing with manufacturing the future. Manufacturing the future or manufacturing the future. And it's really about ensuring both prosperity and security in the United States. So let's take a look at, first of all, I want to thank some of my colleagues, Dr. Tom Feldhausen, Dr. Kyle Salibi, Dr. Vincent Paki. So we're really bringing together, we're going to be talking about hybrid. So this is both additive and subtractive manufacturing, digital and security. So you heard about cybersecurity. We'll mention a little bit about that. And then a lot of the AI. So a lot of the digital stuff really drives a lot of our artificial intelligence and machine learning. So, and of course, thanks to our colleagues over at the Department of Energy for funding the laboratory. So in terms of our operation, we're really about, our unofficial mantra is innovating faster than the competition can copy. And really what we're about is taking whatever the latest and greatest technologies are that are out there, and there may be very nascent, so maybe benchtop type technologies, and working with, and this is very important, we're working with a partner, whether it's an industry partner or a government partner, to take that technology and scale it so that it's at production level. So if you're familiar with the technology readiness levels, going to about a TRL 8, which is something like a pilot plant, but really taking technology, scaling it up rapidly. And I'll talk about our plants, but I will, look, I know this is better buildings, so I'm thinking about better plants here, but I will talk a little bit about some building stuff as well. So that's coming up. So the bottom line is we've got these connected factories, but they're looking a little bit different than what we had before. And the connected factory really has a backbone. And it's using commercially available communication capabilities and so forth. So the machines might be connected up. In fact, machines that are even produced 5 or 10 years ago with state-of-the-art controllers, they will have capabilities like MT Connect, which is a communication standard, or OPCUA communication standard, and they can be connected to the network and get all sorts of information out. In fact, really, the experiments that we might have run 30 or 40 years ago, where we put sensors on machines and then ran experiments and analyzed it, and this would have happened over months, those sensors are now on the machine. And so those data are freely available. You just have to tap into them and then make use of it. And then, you have things like, Google Cloud and so forth, or Azure and so forth that are easy to get to. Some of them, if you think about Google, you've got 15 gigabytes free. So there's a lot of capability out there that people can tap into. And we'll talk about how you might use some of that. So let me give you a really simple example. This is a company we're working with, and they produce turbine blades. Now, they're not they don't make a lot of turbine blades at once. It's just a replacement blade. So maybe 1 or 2 of the same blade, and that may happen once or twice a year. And so one of the things they were curious about is, well, how long does it take me to make the blade? So we said, look, there's a plot of your spindle RPM, and that's just coming directly off of the machine. And that spindle RPM just tells you, yeah, the machine is running. So while it's running, I'm making the blade. While it's not running, I'm not making the blade. So in this particular case, you see 2 different blades being made. And that'll tell you the production time for the blade. And so over the course of a year, we might have made 10 or 15 or 20 of these blades, and we can get an average and standard deviation for those blades. Well, that's great. And so now we have information on production capacity. But what's really interesting is I looked at that blank space in between the 2 blades, and that tells me the setup time for the second blade. Turns out the setup time is the bigger amount of time in this particular instance. And what we found actually when looking at the setup time for an individual blade is the standard deviation, the variation of that setup time was all over the place. It was really big. And look, hindsight is 20/20. What we learned is, if those 2 blades are similar in nature, then the setup time is small because I don't have a lot of tooling changeover. If they're very different, the setup time is big, a lot of tooling changeover. And again, hindsight is 20/20, so that's fantastic. But the company didn't think about this because you'd never really looked at it in this fashion. But the data were there. They were free. They were there. They were available. We saved them 17% downtime on their systems by taking a look at this. By the way, if those machines, and those are relatively new machines, maybe 5 years old or so, if those machines were legacy, we could have just put a little accelerometer like on your smartphone, and that's a few dollars for the accelerometer. So machine vibrating, making a part. Machine vibrating, not making a part. And the cost of that smart sensor, and by the way, we would have something like an Arduino in there and the whole bit, and just to calibrate you, putting Neil Armstrong and Buzz Aldrin on the moon, 8K of RAM. And not 8 gig, not 8 meg, but 8K of RAM. So these systems today that you're getting for $10, $20 that your kids are programming in junior high and high school, much more powerful than what it took to put people on the moon. So anyway, so the sensor plus the processor, so a smart sensor, battery, and a closing box, probably about $30, $40, $50. In fact, the most expensive part of that whole smart sensor setup, just vibration testing and then sending the information out, is the box, right? So not the sensor, not the processor, but the box. So these are the types of things we think about. Let me go a little bit further, because they said, well, hey, talk about additive manufacturing, so 3D printing. I'm going to talk really about hybrid. So think about a machine tool now where I can print the material down. In this particular case, we're putting down weld beads. So you can see they're kind of rough looking, and then we're going to machine them nice and clear. But what it allows us to do, if you take a look at this on the picture on the left, this is a 5-axis machine. So we're printing this propeller. We don't need any support structures because we can rotate. And you'll see in the videos in the next one, really how we're printing some of these out. But we can print it out and then we can machine it to the final shape. Really saves a lot of energy, because now I don't need a big block of steel that I had to create. I can put the steel down just as in the areas that I need, and then machine it to get my final finish. So if we take a look at the next slide, so here you can see, actually, and that's just a simulation of printing it, but we're printing this paddle wheel, and you can see that our 5th axis is actually rotating, so we can print without the support structure. But there are a couple of things we need to think about. For example, if you take a look at that picture right next to it, you can see the trajectory or the slicer and so forth. When you're on the inside of that curve, you have to print less material. So again, it's not thinking exactly like your little home printer. It's a little bit differently. And in fact, I'm going to show you a picture. You can see that little, what we call the little loving cup over there. It's got the curved surface. Instead of slicing it in planes, we're actually slicing it in arcs. And as we go to the next picture, we'll show you actually printing that particular curved surface. So this is now a thermal image. So we're printing with thermal imagery as opposed to visible imagery. And you can actually see how we're rotating the entire part to make sure that we're printing straight down so that molten steel doesn't drip off anywhere. And this is how you would print a part. The other cool thing about this is we're spinning around. So we're printing it up in terms of a spiral as opposed to kind of back and forth in terms of how people think. But the neat thing about this now is we can do some pretty interesting things. So one of the things that we've really learned is we said, well, hey, if you do a lot of printing, it generates a lot of heat. And so the deal is, okay, if you have too much heat, and you can see all the way on the far left, that particular one is just printing that, and it's a wall, but it's a surrogate turbine blade. We're printing turbine blades, and we've actually printed functional turbine blades that spin in a hot gas path. If you print it, it gets too hot, and the blade and the wall starts to fall over and so forth, and it doesn't look particularly good. So what we do is we actually measure the temperature. We've got a thermal camera that we're integrating, and this is using standard technology that's available today. We're integrating it, and basically, when we print a layer, if it's too hot, then we have a little bit of a lag. We actually don't print the next layer until it cools down. So you can see now, you can see that second image on there that it's printing much faster, and then it slows down. Now, of course, people get upset because they're saying, well, that's inefficient. So, in fact, the good Dr. Saleeby turned around and said, well, hey, look, if one blade's too hot, let's just print 2 blades at the same time. So what you see in the picture over on the far right is basically we're printing very rapidly. When one blade gets too hot, we go and print a second blade. So now we have complete utilization of the machine for really, to optimize our process. But again, these are systems that are commercially available, but we're integrating more advanced sensors. Now, as I mentioned, I said, well, hey, look, this is the Better Buildings program, so I'm going to show you SkyBAM. SkyBAM is just 3D printing with concrete. But now, instead of using a big gantry, what people have seen in the past, what we're doing here is, if you think about SkyCam from a football game, all right, the bottom line is instead of a SkyCam that's cable driven, we're actually driving a concrete printer. So we're pumping concrete into this printer, and we're actually printing this wall. This wall is actually pretty cool. It was a Department of Energy project. You can see actually the red there. So we have heating and cooling going through the walls. We have sensing in the walls, so we can tell what's going on with the temperature and so forth. And it's very environmentally sound. We're actually putting forward a really nice concrete wall and actually looking at now carbon dioxide capture with these types of walls and so forth. But again, very flexible. It takes about a half an hour to set the system up out in the field, which is great. And where we get here we're using an overhead crane, but we're partnering up with one of our partners, Oshkosh, to use a sky crane actually to support this out in the field. So about 30 minutes to set up. So look, but before I wind up, one of the things I do want to mention, this is a question that often comes to me, is, hey, all this automation, it's the robot and the dishwasher. Where do we get the robot that's going to load and unload the dishwasher? I got to tell you, people are not going away. If you've worked with robots before, right, and you're a better plants person and so forth, I would not trust that robot with my fine china. And so that robot's is stacking and so forth. And so again, robots sometimes have a hard time putting a round peg in a round hole. you want it to stack the dishwasher. This is difficult. Or I want to inspect the plate. Yeah, do I need to pre-rinse it and so forth? So people are awesome. You're not going to replace people, but you're going to get rid of the nasty job of washing the dishes. And that's sort of the key thing here. So it is about workforce development and training. So just a couple of key points as we start to wrap up in terms of the big picture. And by the way, what I'm showing here is Medusa. So this is a 3-robot system. There are 3 robots going, and then you've got a big turntable down there at the bottom, and you're actually printing a very large part. We can print parts that are a couple of meters in diameter and several meters tall and so forth with this one. So again, some really crazy next generation type of systems. But the bottom line is that those systems, they can get the data out, and we can get latest and greatest information to the systems digitally connected. You've got to do it in a secure fashion. I haven't talked about linking securely, but it is important that you link securely. We have an entire new institute, CyMANI, the Cybersecurity Manufacturing Innovation Institute, supported by Department of Energy, that really talks about how do you make sure your plant is secure. But that digital thread, what you're seeing is allowing us to rapidly deploy the latest, greatest technology, not only the technology to the plant, but also to the people using it. So we're looking at things like augmented reality, virtual reality, and so forth, and really leveraging that whole cloud and fog and edge. Edge is processing right there at the machine. Cloud is, of course, I think people know that, and fog is where the cloud touches the edge. But again, highlight, we've got to weave in cybersecurity, and this will make sure that we can protect our proprietary information. And we really do need to support that, and that does support the overall ecosystem. So this is good not only for the big players, the primes, but all the mom and pop shops that make the nuts and the bolts that go into every airplane and every car that are out there. And so what I'd like to do here is basically just to close with my favorite statement from a 20th century philosopher, because it really is about our workforce, and that is what's by Eric Hoffer: in times of change, learners inherit the earth, while the learned find themselves beautifully equipped to deal with a world that no longer exists. And I think that that's really important. It's not just about next generation workforce, but it's about keeping that current generation workforce well-tuned so we can continue to support U.S. manufacturing. Thanks very much for your attention.
And thank you, Tom. Again, a lot of ground that you just covered there. But let me just ask you one question,
Sure.
Because we're talking about technology and, again, rapid change. So what do you see as some of the largest obstacles to the rapid deployment of some of the technologies you're highlighting? And what are we going to do to break these obstacles down?
So I think the 2 biggest obstacles, one is going to be cybersecurity, and that is we just have to make sure that we're secure. And again, it's not just thinking about, well, let's put up well, first of all, you can't say, hey, I'm going to unplug everything. We're not going to plug stuff in. Imagine your life without a smartphone today, right? I mean, it's just not going to happen. So you've got to be plugged in, and it's not an issue of putting up a wall, but you've got to, just like I said, innovating faster than the competition can copy. On the cybersecurity side, we have to stay one step ahead of our adversaries. And by the way, just to point out, 30% of all cyber attacks in the United States are against manufacturing facilities. And most of those cyber attacks are not to break into machines and destroy machines or mess with processes, but to steal intellectual property. The second thing that I really think we need to look at is to make sure our workforce is really spun up. And what we're talking about in terms of technology is not just about, hey, training the next generation workforce, but making sure the current generation workforce fully utilizes these systems. To give you an example, Al, I mean, think about it. You want to go out for lunch. I mean, my mother, she's 82 years old. Probably shouldn't have said that, to 8,000 people. But look, she can bring up her smartphone. I'm going to go to lunch, bring up my smartphone, and see if I need to bring my umbrella. She is accessing a constellation of NOAA satellites generating terabytes of data that are integrated with other terabytes of data from ground-based Doppler radars into our latest supercomputing models running on supercomputers to give you that, weather map that says, yeah, bring the umbrella or no. And so look at, if she can do all of this type of stuff, we should be able to put together the right type of training and apps and so forth so that our current workforce can really leverage what's out there. And I think that that's it, making sure that we really match our workforce with our capabilities, whether it's next generation or current generation. And that's going to keep us at the leading edge and keep us dominant in advanced manufacturing.
Thank you. Thank you very much.
Sure.
And actually, thank you to all 3 of our speakers, our panelists this morning, for kicking us off here and sharing your insights today. So we're going to turn right now to our attendees and give you a little bit of a challenge before we move to question and answer. So we're going to have a quick poll, and through this poll, can you tell us what are you looking to next as a promising new decarbonization effort? Now, remember, we're doing this on slido.com. So go to the event code, #DOE, and to the room, Emerging Trends and Technologies, to join this poll. We're very interested to see what's going to come to the top here. Well, great. We have technology, we have policy, we have supply chains. We've got an incredible set of things. I think you just look at all the things you all are looking to next, and there really is tremendous reason to be optimistic about the pace of change we're all going to be working on together. So fabulous. So thanks for everyone for participating. Now we're going to move to our live Q&A. So if you haven't, again, already gone to Slido, do that now. Slido.com, #DOE, Emerging Trends and Technologies. Submit your questions or upvote existing questions you'd like the speakers to answer. And let's go ahead and get started. So I think we've got some questions coming in. One is following up on a topic we've addressed a little bit, but can certainly see how important it is to everyone. And that really is the issue of an equitable transition. So one of the questions is, how can we ensure the clean energy transition is truly equitable? And can our speakers, our representatives from the National Labs, speak a little bit about how they're engaging with stakeholders and other experts to ensure that what we're doing is inclusive? So who would like to go first on that one?
Yeah, I can start out perhaps. So Kathleen, I mean, thank you for the question. I mean, I think it's an excellent question because again, what I tried also to highlight in our slides that I think we as a scientific community, I think, can honestly do a better job, I think, in bringing and talking to these communities. And what we have learned on two events, again, from the LA 100 study is, and also perhaps on a different area, what we're doing with the Cold Climate Housing Research Center in Alaska, Fairbanks, where our folks up there are very, very engaged with the community. Where they, for example, talk to some of the tribal leaders there. You know, as you all know, this is an area where through climate change, all of this whole village have to be removed because, I mean, the sea ice is moving further out, and now suddenly the waves are really eroding the coastlines, and through the permafrost changes, suddenly the sewer systems are not working. So it's a massive changes happening up there in these communities. And what we've learned there is it's very important that you bring these communities at the forefront into some of the design of the new buildings. You have to have them engaged. And the same was true for LA. When we talk about the change to 100% renewable energy, we had to make sure that we're talking and taking the time to sit down with these communities, listen to them, and with them bring them along. And historically, I think we have not done this so well. And I think this is where we are very excited also with the current administration, where DOE now puts a lot of emphasis onto this to make sure that we are not leaving these communities behind. So the concern, I have to be honest with you all, is that that's very hard to scale because it's time consuming. It's super critical, but it is something where we need to find a way how we bring these people with us, bring them along, talk to them. This will take some resources, but I think it's absolutely critical for the energy transition. And for me, the key answer there is to really go and make the contacts. So take the time and sit down with these communities, understand what the problems are, and then we can incorporate these issues into our research portfolio.
I think I'll just add on to what Martin said, and I can focus on the manufacturing perspective. So you have the OEMs, so let's say the automakers like a General Motors or Ford, that they're going to have to comply to certain new regulations and so forth. And some of them have already committed to, yeah, we're going to completely electric vehicles, for the personal transportation sector. And so what is happening there is they're working closely with their supply chain, because really they have a lot of the engineering know-how, working closely with the supply chain. But then the national labs, for example, with Oak Ridge and our manufacturing demonstration facility, are also partnering with them to make sure that we're moving in the right direction. And really what this does is it helps to de-risk some of the more advanced technology and to help it deploy in a more rapid sense. So really it's leveraging the capability. And Martin would say the same thing, in terms of what's going on with the environment. Really, we're targeting, Angela would say the same thing. We're targeting some of the higher risk areas to really make those technologies more cost effective and viable, so that they are easier to deploy. But not only that, but working, whether it's community or with the manufacturing community or manufacturing supply chain, to make sure that it's not only great in the laboratory, but it gets deployed out to society or to the supply chain.
Yeah, and I'll hop in here just briefly, maybe, just to echo what Martin and Tom have said to a certain extent, is that it absolutely starts with listening and engaging communities that haven't necessarily been part of the discussion heretofore. And I think observing some of the policy development that's happening out here on the ground in the Pacific Northwest, there's definitely a capacity building need to have communities engaged in these conversations. And Martin's also exactly right that when we're talking about the climate crisis, sort of our need to engage at the community scale is somewhat in tension with the speed at which we need to address the crisis. So again, takes dedicated and intentionality around those engagements. I would also say that it's not just technology innovation that we need to be investing in. It's also sort of the financial and the regulatory innovation. I mentioned in the South Landing example how we're working with Washington State and the Clean Energy through the Clean Energy Fund to look at different sort of rate and tariff structures, such that if you're engaged with, say, small businesses in a disadvantaged area of Spokane, like a low margin dry cleaner, family-owned dry cleaner or something like that, and they're helping provide additional flexibility to the grid because they have grid-connected capability. Like, what are the financial models by which they can share in the economic benefits of defraying infrastructure upgrades that the utility might otherwise need to make? So what are the financial models by which we also share the economic benefits of this transition more broadly than historically has been done in the past? I think those are very interesting set of integrated challenges, but exciting to be able to work on them in partnership with the Department of Energy and our national lab colleagues.
Terrific. Another sort of theme through a set of the questions here is really, it's the research to the markets, right? It's a question you always get. How do you get the great work that's going on out into the markets more quickly? And so, a little bit of what you're doing in that space to get the research out. And then there's a variety of questions that are really focused on how we can work to more rapidly benefit small-ish manufacturers, small businesses, smaller manufacturers, and giving them access to either the capabilities of the labs or getting, again, technologies out to them like smart manufacturing. Like, what can we do to help? So maybe we'll start with Tom this time.
All right, and I remember to unmute, so we're good. So the reality here, actually, it's a perfect question. Look, I could go back to my smartphone. This is the beauty of it. So if you think about your car, you used to pay all sorts of money for this navigation system. Now you plug your smartphone in, and when Google or Waze or whomever they update, or Apple, they update their navigation on their phone, it comes to you free. Not, you are paying something for it because you're giving them data, but now the navigation system on your car is also being updated. And I think that this is really the same type of approach, is how do you get that type of update out? And the machines that are out there, when a company buys a new machine, I mean, it's pretty much state of the art. And the real question is, how do you use it? I grew up in a machine shop in the 1970s, and a lot of these shops are still operating in the same way. It's except instead of using paper tape, they're plugging in a USB key, right? And by the way, I should say, cybersecurity warning: don't plug in a USB key. That's always a dangerous thing to do. But the reality is we're already using this type of technology to get that information out via the digital thread. So a secure connection really allows you to get it out there, and then making a really nice human user interface, HMI, that allows you to easily use the technology. So it's there, the pathway is there. And again, the biggest stumbling block, I think, is cybersecurity. So we have to be very aware of that.
Anyone else? Research to markets.
So yeah, I can chime in there as well, perhaps a little bit. And look, it's an excellent question. I tell you, we're always trying to come from when you look historically, and I always here at Enroll, we use solar as an example. It took 30 years to go from the idea of a solar panel to now being one of the cheapest way to produce electricity. And for some of the new technologies, we don't have 30 years. I mean, when you look at just take the 2050 goal and calculate backwards, what you also take to get it into the market, we have about 10 years to get this technology ready. And this means that we need to be we have to be faster in scaling technology. And this is, again, something where we also, to be honest with all of you, having a lot of discussion right now also with DOE to see how can we as an organization, as a whole national lab system, as a complex, how can we scale up faster? How can we take the great ideas from universities, from other fundamental national laboratories, and how can we work with this and then scale it in a faster timeline, bring it to market faster? And this again comes back what I think also what Tommy alluded to, and what we at Enroll, why I also highlight that the importance in industrial collaborations, because I think when you de-risk some of this technology and work fast and earlier with industry, then to take it into their hands to then scale it. Industry, a lot of companies are wonderful and excellent in scaling technology fast and getting deployed. So I think this is the strength for them. But I think we, from the federal supported research, in my opinion, we have to be faster in de-risking technology, building new partnerships in an earlier way. That's why I feel that public-private partnerships for the energy transitions will be so critical to really accelerate the time to market. And still, sometimes the national labs are kept secret. Sometimes, especially for smaller companies, it is too hard to work with us. So we need to make it simpler. We need to streamline the process. I mean, I'm a scientist, so I can say this, but as soon as all the lawyers are getting involved, this is where it's getting complicated. And this is where it's getting very long timelines. So we have to be much more agile. We have to be faster. We have to increase the speed to work with industry. We may have to make it simple that we can, because look, we find a way to make it very simple, to make joint appointments with academia, to bring students and postdocs into our organizations. Why not doing the same with industry? Why not making it simpler? And this is something I think we have to tackle. Otherwise, we cannot scale enough to make the 2035 and 2050 timelines a reality.
Well said. Well said. Angela, you want to jump in?
Yeah, sure. I'd echo a lot of what Tom and Martin have already said. I think that there are some programs that exist that have been sort of on life support the last 4 years, but are making a comeback, like a small business voucher program and things like that, that strive to make the capabilities resident in national labs more accessible to industry, for sure. And I would just also remark that, understanding the needs of industry up front is what makes us more effective at our job. In terms of understanding the more intractable technology challenges. We spend a lot of time in the national labs trying to understand, like, what is the level at which we must demonstrate something like a new energy storage material to make it interesting to industry to pick it up and run with it. And that differs across different sort of technology verticals. So it's not uncomplicated, but that's what makes it fun.
Great. And actually, Angela, another question for you. People are interested in drilling down just a little bit more on the resiliency topic that you brought up. And just so a little bit more on some of the metrics, I guess, around resilience, and then how to get access to some of the tools that you mentioned.
Yeah, I'm happy to follow up through the Better Buildings folks on access to those resilience tools. As I said, we're in the process of sort of doing the trade-off analyses for different sort of how the intersection of efficiency measures and resilience, defined loosely as continuity of operations under a variety of different conditions, are related. And there may be some efficiency measures that accelerate resilience, and there may be some efficiency measures that don't necessarily. And so that's what we're trying to understand right now. For purposes of sort of work in the code space, those are the trade-offs we're trying to understand. In terms of some of the resilience work we're doing with FEMP, we're also sort of building in things like forest fire and other sort of threats to the building stock. And so, like I said, it's an analytical challenge we're working on right now, and happy to follow up through the Better Buildings folks on those sort of trade-off analyses and that suite of tools that we're trying to mature.
Terrific. So let's sort of talk about buildings a little bit more. Variety of questions talking about electrification of buildings. So what are the biggest challenges to electrifying our buildings? But also another question coming in, knowing that it's not just an issue of what fuel goes into our buildings, but how do we get ahead of designing buildings that use the absolute least amount of energy? So whatever it is that's going in, is the least you need to have a nice, workable, livable space. So electrification, and how do you just design efficiency in from the get-go?
So I can kick off because, and I won't take too much time here, but the reality is we do think about this when you're looking at 3D printing the walls and so forth. Okay, this is a whole different way of putting it all together. And really thinking about, so one of the things we can do is we can actually print the wiring directly into the wall. And so we think about, how do you put this all together? You think about your LED bulbs that you have, or your light bulbs, right? They used to screw into an Edison socket. Well, that's no longer the case. I have LED bulbs, so I can actually distribute them around and so forth. So the one of the things we didn't, I showed you some of the software tools and so forth, but there's a whole new generation of software tools that's going to let people think completely outside of the box. Because right now you think about, okay, I'm going to put up a structure and this is what I'm going to do, and I'm going to put wiring up and so forth. But the reality is it's going to be completely different. Even think about switches, right? Do I really need to run copper switches to all of my switches and so forth? Or do I just have, I'm pointing up to my light bulbs over here, do I just have light bulbs that are internet capable? That Wi-Fi chip is pretty cheap. So, do I really need to have all this connection and have all this copper running through my building when I can use Wi-Fi? Now, I'll say that, and I can tell a few people are cringing out there because you also have cybersecurity issues, right? And so, and I think it was just really punctuated by the recent issue with the Colonial Pipeline. So I think that it's a double-edged sword. We really have a great opportunity to be much more efficient. Actually, even on, I'll just say this, on aircraft, they have all these LED lighting now on the aircraft. Why do they do that? It's part of it's energy efficiency, but now I don't have to have all the wiring in there. I can have really, really thin wire, and that saves unbelievable amounts of weight there. So there are tremendous opportunities, not just in terms of energy savings, but in terms of construction cost savings and overall material savings. So it's really going to drive things forward, but you're going to have to think about things a little bit differently.
Great. So it is wonderful when you find these win-win-wins, and of course that is part of what is a new world. So Martin, challenges with electrifying our buildings?
So I think that, in my opinion, it all comes back to all of us. So this is where I want to start, because as you all can hear, being from Germany, when you look at this, how homes are being treated in Germany, it's fundamentally a little bit of a difference than perhaps here to the United States, where you are willing, if you're building a house, to invest from the beginning really into some of the energy efficiency side. As you know, the German houses are in general built in a way where they're putting so much efficiencies measurements in there that sometimes they're having even air quality problems, that they're so insulated that you have to open your windows to a certain time to get the airflow going. So they're sometimes going into the extreme. But this said, I think it takes all of us to take a kind of a path forward that this is important to us for a living in our homes. And I tell you what, coming back, because I mean, when Angela, when you talked about the pandemic, what I'm seeing is that through this horrible times we had through the 15, 16 months, I think a lot of people are also now looking into their homes in a very different way. Using myself, I'm still sitting here in my home office for 15 months. So I'm starting to enjoy my house in a very different way than perhaps even before the pandemic. And I think this is a great opportunity for us to really realizing that we're putting some of this kind of new measurements into our homes, that we are seeing this more as an active environment where we're spending a lot of times, that we're investing into some of these new technologies coming, that we taking pride in having efficiency in our houses, which the question is absolutely correct. I mean, every electron you save is a double win. So we need to put efficiency into our homes. So, and then frankly, what I see on the electrification of our homes, one of the biggest challenges, what I'm seeing is some of our customs. I mean, I personally, our family, we still love to cook with natural gas. So I love to have my flamer and saute my little onions. And changing this to electric is, I grew up in Germany with an electric stove, but of course now, how do we go back to this in this case? How do we change our behavior? And again, this is why a lot of these things, I think we need to put more emphasis onto the social science aspects. Sometimes we as scientists, we're just looking at technology, but we're forgetting to work on the social side to see how this is adapted. At NREL, I mean, I give you this example. When I moved from Oak Ridge into NREL, into my office, well, of course at Oak Ridge, I just was able to plug my coffee maker into my office, and then at NREL, they told me, no, you can't do this. So what do you mean I can't do this? Now, because we have a net zero office building. So I had to learn to adapt that we've done it differently. So I had to go to a central kitchen to take my coffee. So you need to adapt. You have to adjust to some of these new kind of measures. And this is why social science, I think, is so critical, that we joining this, that we understanding what do the consumer want, how to develop technology, which is then also adapted and implemented to our homes. And sometimes we uncouple the two. And I think this is what I would say, looking forward, in my view, the most important element, to combine the two together.
Fabulous. Angela?
I'll add a few things to the mix. In terms of commercial buildings in particular, we're running sort of an experiment out here in the Pacific Northwest. The Washington State Legislature passed a Clean Buildings Act in 2019, which is a set of incentives which will ultimately migrate into mandates for commercial building owners to participate in performance-based building program. And so sort of making that shift to performance-based operations rather than sort of prescriptive, this measure and this measure and this measure is sort of the 45-degree turn in the commercial building space we're trying to execute in Washington State. I would add that on the question of electrification of appliances and systems, part of it is ensuring we're manufacturing the kinds of appliances and systems that consumers want to buy. To Martin's point about natural gas stove, we've made those market transformation related mistakes in the past where performance of the appliances isn't necessarily up to what the consumer demands, which doesn't end up well for anyone. So there's more to be done, I think, in that space. Finally, and this is based on really like N equals 4, based on my experience with like doing things in my own home, workforce is a non-trivial challenge in terms of boots on the ground to install my, the common wire for my, smart thermostat and my heat pump technology in my own home. Like the workforce challenges are real and really deserve a lot of attention, I think, because it's one of the sort of the soft factors that are going to make or break this transition, I think, in terms of having the workforce that knows how to execute on these new technologies and making sure we're, again, as I said, intentional about ensuring that we're skilling the workforce appropriately for this. So,
great. So let's talk a little bit more about manufacturing and some of those better plants, or the intersection between some of the manufacturing and homes. We have a question about the cement, and cement being such a CO2 intensive material. Can you speak to how you see the future of cement in this country, Tom? And then a related question, what are some of the other fuels out there that you see being part of a decarbonized manufacturing sector?
Sure. So certainly, one of the things we look at in terms of cement is there cement or is there concrete out there that you could actually, that actually absorbs the CO2, and so you actually have a negative CO2 footprint as you produce it and so forth. And so these are the things that we do take a look at. Can you put it down? Can you make use of it? Can we actually use it as a surrogate material, even in replacing? We're now building machine tools, for example, and instead of having a steel base where you've got a casting iron and then there's a lot of heating and so forth that goes on there, we're actually using concrete as the base. One would think, oh, concrete is a very good base. It turns out, yeah, it actually works out pretty well. One of the things you don't want your machines to do are to ring. If you ring a bell, right, it's made out of metal, it rings quite nicely, it vibrates quite nicely. If that same bell is made out of concrete, you hit it, you get a thud. So I think that there are a lot of opportunities, and we're working with a number of our partners, like Quikrete is one of our partners, in terms of designing the concrete appropriately. The other really nice thing about it is really you produce concrete at a local level. So you don't produce it here in one part of the country and then ship it all the way across to another part of the country. So you get rid of those transportation costs. One of the things that we are looking at, but this is something a little bit further down the road, is can you recycle it? So can you grind it up and reuse it? And what about the aggregate and using it in terms of aggregate? So I think that there are a lot of good opportunities in there. What was the? And I'm sorry, I got so excited about concrete. And by the way, I got to tell you, if you go to Home Depot, take a look at concrete, the cost of concrete, and take a look at the cost of a bag of topsoil, and you'll find out that concrete's cheaper than dirt, right? So I mean, it's a pretty good material. And again, if it's absorbing CO2, life is really good. What was the other part of the question, Kathleen?
The other part is, as you look at deep decarbonization of manufacturing, what kind of fuels do you see that sector moving toward?
Sure. Well, I mean, I think Martin and sort of given sort of the National Renewable Energy Laboratory, I think Martin will probably have some great comments on that. NREL, you can see right on his shirt. But the reality actually is we do see a lot of look, the manufacturing sector, a good chunk of it, at least on the machine tool side and so forth, is driven by electricity. So things like wind power, things like solar are going to be great for us. Now, of course, wind's not always blowing, sun's not always out. So you've got batteries. So a lot of work that's going on in the transportation sector with automotive is also going to be very useful, on the manufacturing side, on the home side. So once these batteries in these cars are not quite, they don't quite get to the same full charge, can we use them somewhere else to store that electricity? And of course, one of the really big things we're looking at are small modular reactors. So can we produce small modular nuclear reactors completely different, right, than what the current reactors look like? Everybody's afraid of nuclear. We know what happened in Chernobyl and 3 Mile Island. These operate completely differently. And we're actually making these things using 3D printing technology. So 3D printing a small modular reactor, which allows us to make them much more cost effectively, much safer, and to use completely different designs so they don't get really hot. So things like meltdowns can't possibly occur. And so I think that there are a lot of good opportunities there, whether it's how we're going to use things, how we're going to make things, or how we're going to make next generation things using the latest technologies are really going to make a big effect on that. But I'll defer to some of my other two colleagues to talk a little about their thoughts there, because I can see some smiles on the other end of the line there.
Sure. Angela,
Go ahead, Angela.
Sorry.
Yeah.
So, in terms of fuel sources for manufacturing, I mean, as Tom was saying, a number of us are looking at electrification of different sort of metals processing and extrusion processes, which hold a lot of promise. Working with the Advanced Manufacturing Office and Vehicle Technologies Office, for example, and sort of joining of dissimilar materials and how we can use different electrified manufacturing processes on this. I think, and Martin will probably elaborate on this, given the electrons to molecules work that NREL is engaged in. Everybody's sort of looking at hydrogen and its role in the manufacturing sector, and how we would understand the scale required to produce those fuels, I think is at the forefront of the need to know right now as we look at decarbonizing the industrial sector. So Martin.
Yeah. So look, I mean, you brought up a lot of good points in it. When you look at industry, I mean, I think we have a good path forward on the electrification side. I mean, we have different ways to create electricity. So I think this is, and especially right now, already wind and solar is in many areas cheaper than even a combined natural gas cycle. So I think this trend will continue. The problem still is the so-called process heat, because there's not so many technologies to really create a very high temperatures, and a lot of industry processes require significant process heat. And this, I think, it will be very interesting how we develop and create this process heat. So we could go into hydrogen again. That's Inshallah talked about this, where we're using what we call electrons to molecules, where we very likely probably could take a renewable electricity and go through electrolyzers to create hydrogen. And then the question is, will hydrogen then be transformed into other hydrocarbons, or will it stay as hydrogen? So that's one question we still really don't know where the technology will go. The other interesting element from process heat, you could say that you could use concentrated solar potentially, especially if you combine this with geothermal, could be very interesting for process heat. And Tom mentioned small modular reactors, which also could produce nice process heat. There's another very interesting field developing, and this is, again, I saw there was one question in there to see what other technologies other countries are doing, especially also in Europe, especially also in Germany. There's a lot of new emphasis put into this high temperature heat pumps. And this is something which, again, we are also starting to check into this, because this could be an interesting element, to take heat pumps towards producing process heat. I mean, I would say that from a technology perspective, they're very early in development. But the key is overall, how do we produce process heat in a sustainable way and not using natural gas? Or if we need to have natural gas, can we decarbonize our gas pipelines? So we're working on processes, where you could use electricity through hydrogen, and we're having a process also funded with so-called gas that we're producing kind of methane in carbon neutral way through a microwave process in this way. So there's other ways potentially to decarbonize our natural gas system, which would be very interesting, because our natural gas pipeline is a tremendous storage opportunity for energy if we know how to decarbonize natural gas. So, but overall, especially in certain industries like steel, and others, process heat is a big issue. We still have to work this.
Great. And still sort of on the manufacturing topic, there's some questions on manufactured, sort of site manufactured, manufacturing here, homes, right? The intersection for like a new generation of homes that are manufactured. So what's the thinking on that front?
Sure, and I'll just kick it off again, since manufacturing, and I think there are a couple of things that are going on. People like to think about 3D printed homes, and I think that's fine. What you see out there in general are these big gantries that you've got to set up and so forth. You've got something like Skydam now, where you could set up four corners of the box and put the crane in there, and then you can print it that way. But so you can print a complete home. But the other thing really that we're seeing in terms of manufacturing is a lot of prefabrication. So if you look at a house today, many of the beams will even come, or even sections of the house will come. If you look at your sort of roof structure, your framing structure will come. And we can even think about, well, we might 3D print the brackets that hold it together, or we might actually 3D print the dies that you stamp the brackets out of, and so forth. So it's not just, well, we're going to go from building a stick-built house to a 3D printed house. I think that there are different levels that you can go after and really look at scaling it up. That being said, I think that there's also something to be said, since we're talking about a digital and a digital manufacturing capability. You could really look at point of consumption manufacturing. So that basically means, I can produce these elements, whether it's an entire framing structure or just brackets that I use to put things together. I can print all those and get those together locally and make use of it. And the last thing I'll talk about is we have some large polymer 3D printers where we take the plastic, and we're even talking about recycling 2-liter bottles, right? You could take the plastic, mix it in with what they call wood powder. It's really sawdust, And so now you're capturing that carbon. You've got the, sort of fairly good material. In fact, it lowers the cost because the sawdust is cheap. And you can actually print out things like 2x4s, and they're pretty indestructible to the weather, so they're not going to rot and so forth. And that actually could save you in terms of Walmanized or pressure treated wood. You don't have to go in that direction. So there are a lot of things that can happen just to get you to a house that has 3D printed components in it. I said you could even 3D print your 2x4s if that made sense, right? And by the way, it can make sense. We're 3D printing telephone poles for use out, in hurricane-stricken areas where you've got a bunch of scrap wood. I can grind it up, mix it with the plastic, print the poles out, and I have to bring the poles in. So these are a lot of things that you can think about in terms of construction.
Fabulous. Martin, Angela?
So I just want to highlight one project, and this comes back to the environmental and energy justice. So one project which really took a lot of my attention is what we have done through the Cold Climate Housing Research Center in Alaska, where they again worked with this community and said, how can we change when we have whole villages have to move to a new location? How do we bring these buildings up to the next standards? And the path they took up there was very interesting, and it is a little bit the hybrid. I think what Tom just described. They started to design the homes where the expensive parts of a house. What is this? It's the kitchen, it's the bathrooms, and a lot of the plumbing assigned with this. So they designed with this community these modules where you basically in a container bring the bathroom, the kitchen plumbed all together. You can easily ship this. And then the local communities build the house around this kind of inner cell, which then the communities can build based on their needs. I mean, some of the tribes want to have very specific meetings areas where the family comes together. They want to have the bedrooms aligned in a certain way. So they want to have, especially with all the wind going around, so that you go when you have an entrance, which is then where you take your clothes and your shoes off. So basically you bring the local community where you very easily can teach some of the folks really to build the structure around these modular cells, which are the expensive part. So you then can build this in a manufacturing in a bigger place. It's easy to barge them, to ship them into these areas, and then you use a local workforce to develop the homes around this. And this concept, in my opinion, is not just an interesting concept for Alaska community, but also, for example, talk about FEMA. If you have hurricanes destroying whole neighborhoods, you easily could then develop this where the centerpiece can be manufactured, even be prepared ahead, and then people can customize their homes for how they want to have the houses around this. And this is, I think, a very new way, I think, of building, where you bring the energy efficiency and the expensive components, you make them in a manufacturing place, and then you have this custom-built homes with the local community. And I think a little bit also where Tom is going, hybrid, where you're not making all of this in a manufacturing place, you custom build it, but you still have the centerpiece designed to create the most energy efficient way and the best way to get the plumbing and electricity done.
Fabulous. Angela?
Yeah, I would just say,
I think you get the last minute here.
Sure, the last minute. Manufacturing components and assemblies out of new materials is central to what we're seeing in terms of like the net zero carbon building experiments we're running out here for sure. And cross-laminated timber in particular is of interest given the resource we have here in the Pacific Northwest. And this is a case where, frankly, we're learning from industry about better managing their supply chains, where a lot of savings can come accrue as well. So thank you.
Fabulous. Fabulous. So I think that really is all we can fit in today. And we did cover amazing territory with a lot of really good questions. So let me thank our audience. And let's also thank you, of course, to Martin, Angela, and Tom for being part of today's session. It's really been great. So as you can see, there is a lot of very exciting work going on at the National Labs and some terrific people thinking about that and what's coming next. So before we close, we do want to remind you that through the Better Building Solutions Center, there are more than 3,000 solutions to help you find proven and cost-effective strategies and to help you reach your goals for energy, water, and waste reduction. So please check out this video to learn more. Great. One other thing I want to highlight to you all is to invite you to attend the Better Buildings Summer Webinar Series starting in June. Through this series, partners discuss some of the pressing topics they're facing. They share their best practices and the new approaches that they're using for sustainability and energy performance. And it's easy to register at the Solution Center by clicking on events and webinars. So let me just close again by thanking our panelists very, very much for taking the time to be with us here today. We have launched a short feedback survey in Slido and ask that you please take a couple minutes to give us the feedback on the session. It is certainly through your feedback that we can keep providing to you really great sessions as part of the Better Buildings Summit, as well as the other Better Buildings events. So the poll will be open until tomorrow morning, and please send us your information. So again, thank you all, our panelists, and to you especially, our attendees today.